Unit 4. Scaling of MOS circuits. Okay, guys. What is a scaling of MOS circuits means? All of you know that. What is a Moore's law? Anyone can say what is a Moore's law? Any one of you can say what is a Moore's law? Number of transistors on a chip for doubles for every 1.5 year. Means for every 18 months, the number of transistors on a chip doubles. Means how the number of transistors on a chip doubles means. Here, for every year, we will decreases the size of a MOS circuit. That's why the number of MOS transistors on a chip will doubles for every 1.5 year. Okay, so scaling means how we will decreases the dimensions of a MOS circuits. We have a different types of scaling models. See here now. First, I will discuss scaling models. We have a mainly rarely used scaling model. Commonly used scaling models. We have a 3 different types of scaling models. These are the scaling models commonly used. One is a constant electric field scaling. Constant electric field scaling. Scaling model. And second one is a constant voltage scaling model. Constant voltage scaling model. And third one is a combined voltage and electric field scaling model. These are the 3 commonly used scaling models. What are those means? One is a constant electric field scaling model, and a second one is a constant voltage scaling model. Third one is a combined voltage and electric field scaling model. And what is the difference between the 3 scaling models means? We have a different types of scaling factors. What is the scaling factors? So what are the scaling factors means? Commonly used scaling factors are 1 by alpha and 1 by beta. These are the commonly used scaling factors. When we will use a 1 by alpha means for supply voltage and so 1 by alpha is a scaling factor used for 1 by alpha scaling is used for supply voltage, means supply voltage and other voltages. For voltages, we will use a scaling factor as a 1 by alpha, and supply voltage like VDD, and it is also used for oxide thickness. That is capital D. And 1 by beta is a scaling factor used for linear parameters like vertical and horizontal dimensions of a surface, our MOS surface. What is 1 by beta is used for linear dimensions like vertical and linear dimensions. What is a 1 by beta is a scaling factor used for linear dimensions, means like a vertical and horizontal surface, horizontal dimensions of a surface. Means let us consider length and width. These are the examples of a length of a transistor. It is a length means let us consider it is a length of a transistor. It is a vertical dimension, and let us consider width. It is a horizontal dimensions. For horizontal and vertical dimensions of a linear, those are called as linear dimensions. For these dimensions, we will use a scaling factor as a 1 by beta. And what is for combined voltage and electric field scaling model, we will use both 1 by alpha and 1 by beta. Means we will use a 1 by alpha and 1 by beta scaling models for combined voltage and electric field scaling. But for what about for constant electric field model, we will use a beta is equal to alpha. And for constant voltage scaling model, we will use a beta equal to 1. And commonly used scaling models are constant electric field scaling model, constant voltage scaling model, combined voltage and electric field scaling model. And scaling factors are, we will use 1 by alpha and 1 by beta as a scaling factor. 1 by alpha scaling factor is used for supply voltage and oxide thickness, so it is a capital D. And 1 by beta is scaling used for linear dimensions like vertical and horizontal dimensions of a surfaces. For that purpose, we will use a 1 by beta as a scaling model. So for combined voltage and electric field scaling model, we will use both 1 by alpha and 1 by beta. For constant electric field scaling model, we will take beta equal to alpha. Similarly, for constant voltage scaling model, we will take beta equal to 1. And next, we will calculate what are the different scaling factors for device parameters. Now, we will calculate scaling factors for device parameters. Okay, for first parameter, I will take it as a gate area. Let us consider the gate area is a AZ. So what is the formula for area? Gate area, what is the formula for area? What is the formula for area? Am I audible to everyone? Hello, am I audible?
Yes, sir.
What is the formula for area?
Length into breadth, sir.
Yes, the formula for area is length into width. And we have a scaling factors 1 by alpha and 1 by beta. These are the scaling factors. 1 by alpha is scaling factor used for supply voltage and remaining voltage and oxide thickness, whereas 1 by beta is a scaling factor used for linear dimensions, means like horizontal dimensions and vertical dimensions of a surface. Examples are length and width. So what is a, now I want to find the scaling factor for now I want to find the scaling factor for gate area. All of you know that the formula for gate area is a L into W. Now I want to find the scaling factor for gate area. Now what is the scaling factor for L? See here, for linear and horizontal dimensions, the scaling factor for linear and horizontal, sorry, for linear dimensions, means vertical and horizontal dimensions, we have a, sorry, 1 by beta is the scaling factor for voltage and, sorry, I have given it. it is a 1 by beta here, 1 by alpha is here. So 1 by beta is the scaling factor for supply voltage and oxide thicknesses, whereas 1 by alpha is the scaling factors for linear dimensions like vertical and horizontal dimensions of a surface. So for L and W, these are the vertical and horizontal dimensions of a surface. So the scaling factor for this one is a 1 by alpha. So now what is for L, we have a scaling factor 1 by alpha. Similarly for W also we have a scaling factor 1 by alpha. Okay, so remember this. Previously I have made a mistake here. 1 by beta is the scaling factor for VDD and oxide thicknesses, whereas 1 by alpha is the scaling factor for linear dimensions like LW. So here for calculating gate area, the formula for gate area is a L into W. So for L, it is a 1 by alpha, and W, it is a 1 by alpha. So 1 by alpha into 1 by alpha means it is a 1 by alpha square. So the scaling factor for AG is a 1 by alpha square. Similarly, second one is a next we will calculate a scaling factor for gate capacitance per unit area. Next, we will calculate a scaling factor for gate capacitance per unit area. It is a C naught or COX, gate capacitance per unit area. The formula for gate capacitance per unit area is C naught equal to epsilon OX by D, oxide thickness. The gate capacitance per unit area is it is having a formula epsilon OX by D. It is a thickness. So it is a epsilon. What is a epsilon means? What is a epsilon?
Permittivity.
Yes, it is a permittivity and it is a constant value. There is no scaling factors for constant value. Now I want to calculate a scaling factor for C naught. So what is a epsilon OX? There is no scaling factor for epsilon. It is a constant value, so there is no scaling factor. So what is a scaling factor for oxide thickness, capital D? See here, the only 1 by beta is scaling factor for supply voltage and other voltage and oxide thickness. మనకి 1 by beta ఈ రెండింటికే స్కేలింగ్ ఫ్యాక్టర్ ఉంటుందమ్మా. VDD ఏవైనా ఇంకేవైనా వోల్టేజ్ వచ్చినా 1 by beta స్కేలింగ్ ఫ్యాక్టర్ ఉంటుంది. అలాగే ఆక్సైడ్ థిక్నెస్ కూడా స్కేలింగ్ ఫ్యాక్టర్ 1 by beta ఉంటుందమ్మా. రిమైనింగ్ అన్నింటికి కూడా స్కేలింగ్ ఫ్యాక్టర్ అనేది 1 by alpha ఉంటుందమ్మా. సో వాట్ ఈస్ ద స్కేలింగ్ ఫ్యాక్టర్ ఫర్ D నౌ? 1 by beta. Why? Because 1 by beta is the scaling factor for oxide thickness. So I am placing for D, I am placing a 1 by beta. Now beta is now scaling factor for C naught is a 1 by beta, which is a beta. Scaling factor for gate capacitance per unit area is a beta. Next one is a gate capacitance. Third one is now we will calculate a next page. Screen is visible?
Yes, sir.
Now tell me what is the scaling factor for CG? What is the scaling factor for C naught here? We got C naught ki scaling factor ఏమొచ్చిందమ్మా?
Beta, sir.
Beta. Now tell me what is the scaling factor for CG? The C naught having a scaling factor beta. What is the scaling factor for L?
1 by alpha, sir.
Yes, it is a 1 by alpha. What is the scaling factor for W?
1 by alpha, sir.
1 by alpha. Now, what is the scaling factor now? Beta by alpha square. The scaling factor for CG is beta by alpha square. I think, are you following my calculations? ఏం లేదమ్మా మీరు ఇది గుర్తుంచుకుంటే చాలు. వాట్ ఈస్ స్కేలింగ్ ఫ్యాక్టర్ ఫర్ VDD and thickness is 1 by beta. Remaining అన్ని పారామీటర్స్ కూడా ఆల్మోస్ట్ the scaling factor will become a 1 by alpha. Okay, so in this way we will calculate the scaling factor for different parameters. Now the CG is having a formula C naught into L into W. For C naught already we have calculated a scaling factor which is a beta, and for L we know that for L the scaling factor is a 1 by alpha, and for W also the scaling factor is a 1 by alpha. The total scaling factor will become so beta by alpha square. Now all of you tell, next one is a scaling factor for parasitic capacitances. Sorry, parasitic capacitance. Next, we will calculate a scaling factor for parasitic capacitance. Parasitic. It is a Cx, and it is a Cx equal to Ax by small d, whereas D is a diffusion with depletion. Depletion with now. Tell me the scaling factor for Cx now. Any one of you tell me the scaling factor for Cx. What may be the scaling factor for Cx?
Sir, beta by alpha.
Actually, the Ax is having a scaling factor. Area ki scaling factor antama
1 by alpha square, sir.
You check. The okay. Earphones unnaya. The area is having a scaling factor 1 by alpha. Ma oka capital D ke scaling factor anedi
Beta 1 by beta, sir.
oka capital D ke 1 by beta ma. It is a small d which is a depletion width, and it is having a scaling factor 1 by alpha only.
Yes, sir.
Capital D ki voltages ki maatrame scaling factor 1 by beta. Remaining అన్నింటికి కూడా scaling factor అనేది 1 by alpha only. So 1 by alpha square by 1 by alpha is same
1 by
వస్తుందమ్మా?
alpha. 1 by alpha.
Yes, the scaling factor for parasitic capacitance is a 1 by alpha. Okay. Next, fifth one is a next parameter is a carrier density in channel. Carrier density always proportional to the charge. Why? Because the carrier density depends upon charge only. So what is the formula for Q on equal to C naught into VGS? Now tell me, what is the scaling factor for Q on? Now calculate what is the scaling factor for Q on. What is the scaling factor for C naught? C naught కి మా scaling factor వచ్చింది మనకి. Scaling factor for C
Beta,
naught.
sir.
Yes, the scaling factor for C naught is a beta. Voltage ki scaling factor ఏమని చెప్పానమ్మా? VDD supply voltage అయినా ఏ voltage అయినా
1 by beta,
VGS.
sir.
Yes, it is a 1 by
1 by
beta.
beta.
Now, what is the scaling factor for Q on?
1.
Yes, the scaling factor for Q on is a 1. So, it is having a scaling factor 1. And next one is a channel resistance. Next topic is a channel resistance. R on. So I will give the formula for channel resistance. R on is equal to all of you calculate the scaling factor for R on. So it is having a channel resistance L by W into 1 by Q on into mu. So the channel resistance R on equal to L by W into 1 by Q on into mu. So what is the scaling factor for L? Now all of you calculate the scaling factor for R on. What is the scaling factor for L? L ki scaling factor entama?
1 by alpha.
Yes, 1 by alpha. What is the scaling factor for W?
1 by alpha.
1 by
1 by
alpha,
alpha.
sir.
What is the scaling factor for Q on? మనం calculate చేసాం కదా. Yes, Q on is having a scaling factor 1. And what is the scaling factor for mu? What is your mu means? What is your mu means?
Mobility, sir.
Mobility means it is a constant value. For constant values, there is no scaling factor for constant values. We will take it as a 1 only. For constant values, we will take a scaling factor as a 1 only. So, what is the scaling factor for R on now?
1, sir.
And the R on also, the scaling factor for channel resistance R on also equal to 1. And next one is a gate delay. Gate delay, it is represented with TD. TD equal to, what is your formula for delay? Delay formula entama? R into C. I already told you that delay is having a formula R into C. So it is equal to R into CG. So now calculate the scaling factor for TD now. Now calculate the scaling factor for TD. What is the scaling factor for R on? Yes, it is a 1. What is the scaling factor for CG? We already calculated the scaling factor for CG. So what is the value of scaling factor for CG? Gate capacitance?
Beta by alpha square.
So we have to replace it with a beta by alpha square. So finally, the scaling factor for TD is also becomes beta by alpha square. And next one is a scaling for a factor for maximum operating frequency. And the formula for maximum operating frequency F is equal to, the F is having a formula W by L into mu into C naught into VDD by CG. Now, all of you calculate what is the scaling factor for maximum operating frequency. Any one of you tell final value of maximum operating frequency scaling factor.
1 by alpha could mu naught 1 C naught 1 VDD 1 by alpha by CG alpha beta by alpha square 1 by VDD 1 by beta by beta by alpha square beta square by alpha square.
Alpha square by beta.
Yes, alpha square by beta. So W is having a scaling factor 1 by alpha, whereas L is also having a scaling factor 1 by alpha. What about mu naught? Mu naught is a constant value. It is having a scaling factor 1. What is the scaling factor for C naught? Already మనం చేసిందేనమ్మా. Scaling factor for C naught is a beta. And scaling factor for VDD is a 1 by beta. And scaling factor for CG, gate capacitance is a, what is the scaling factor for gate? Beta by alpha square. So it is having a formula beta by alpha square. So ఈ రెండు క్యాన్సిల్ అయిపోతాయమ్మా, అలాగే బీటా బీటా క్యాన్సిల్ అయిపోతాయి. సో ఫైనలీ వీ హ్యావ్ ఎ స్కేలింగ్ ఫ్యాక్టర్ ఫర్ ఎఫ్ ఈజ్ ఏ ఆల్ఫా స్క్వేర్ బై బీటా. అర్థమైందమ్మా ఎలా క్యాలిక్యులేట్ చేసామా?
Yes sir. Yes sir.
Next one is a saturation current. Scaling factor for saturation current IDSS. I will give formula for IDSS. All of you find the scaling factor for IDSS. IDSS is having a formula C naught mu by 2 into W by L into VGS minus VT whole square. Now all of you find the scaling factor for IDSS. ఏమొచ్చిందమ్మా, ఎవరైనా ఫైన్ చేశారా ఐడిఎస్ఎస్ స్కేలింగ్ ఫ్యాక్టర్? ఇక్కడ చూడండి, వాట్ ఈస్ ద స్కేలింగ్ ఫ్యాక్టర్ ఫర్ సి నాట్ కి స్కేలింగ్ ఫ్యాక్టర్ ఆల్రెడీ ఇక్కడ చూసుకున్నా బీటా. మ్యూ అనేది కాన్స్టెంట్, స్కేలింగ్ ఫ్యాక్టర్ ఉండదమ్మా. 2 అనేది కూడా కాన్స్టెంట్, స్కేలింగ్ ఫ్యాక్టర్ ఉండదు. W is having a scaling factor 1 by alpha. Similarly, L is also having a scaling factor 1 by alpha. All of you know that the voltage is having a scaling factor beta. So VGS minus VT by beta whole square ఇలా తీసుకోండి అమ్మా. సో 1 by beta కామన్ తీసిస్తే 1 by beta square into VGS minus VT whole square వస్తుంది. So the scaling factor for VGS minus VT whole square is a 1 by beta square. Why? Because the scaling factor for VGS is a 1 by beta. So VGS by BT minus VT by beta whole square. So 1 by beta common తీస్తే VGS minus VT whole square. So the scaling factor for VGS minus VT whole square is a 1 by beta square. ఇది కన్ఫ్యూజ్ అవ్వద్దమ్మా. Okay, so it is having a 1 by beta square. So 1 by alpha gets cancelled. Beta by beta square. What is the final scaling factor now becomes 1 by beta. It is a scaling factor for IDSS. Next one is a 2 endukama.
సార్ కింద 2 ఉంది కదా సార్, C0 mu by 2.
C0 mu by 2 for 2 is a constant value. 2 is a constant value. For constant values, we have to take a scaling factor as 1. 2 mu epsilon, these all are constant values. For constant values, we will take a scaling factor as 1. 2 ante adi constant value amma. Daniki kuda scaling factor we have to take it as a 1. So beta into 1 by 1 అని అందుకే రాశాను. అర్థమైందా?
Yes sir, అర్థమైంది.
Next one is the current density. IDSS is having a scaling factor 1 by beta. Next one is a current density. So what is the formula for current density? What is the formula for current density J? Current density formula etama? Nobody knows the formula for current density. I by A. IDSS by A. Okay. Now find the calculate the scaling factor for J. What is the scaling factor for JKM? What is the scaling factor for IDSS? ఏమొచ్చిందమ్మా scaling factor?
1 by beta.
1 by beta.
Yes. What is the scaling factor for area?
1 by alpha square.
So what is the scaling factor for J now?
Alpha by beta.
Alpha square by beta.
Alpha square by beta. Now it is a scaling factor for current density. Okay, next one is next I will give you formula, all of you calculate. Switching energy per gate. It is easy. Switching energy per gate, easy. I will give the formula. All of you calculate now. Scaling factor. Easy is having a formula CG by 2 into VDD square. CG by 2 into VDD square. Now calculate the value of a scaling factor. Calculate చేసారమ్మా, ఏమొచ్చింది ఈజీకి స్కేలింగ్ ఫ్యాక్టర్?
1 by alpha square.
1 by alpha square. Yes.
Beta.
1 by alpha square beta. The CG is having a scaling factor. All of you know that the CG is having a scaling factor beta by alpha square. So CG is having a scaling factor beta by alpha square. And all of you know that 2 is having a scaling factor 1. 2 is a constant value. It is having a scaling factor 1. And VDD square. For voltages, we have a scaling factor beta. VDD square means it is a 1 by beta square. VDD square and scaling factor 1 by beta square. Now the scaling factor equal to 1 by alpha square beta. It is a scaling factor for easy. Next one is a power dissipation per gate. Also. Pg equal to power dissipation per gate means so Pgs plus Pgd. And the formula for Pgs is Pgs equal to Pdd square by R on, and the formula for Pgd is Eg into F naught. Now calculate the scaling factor for PGS and PGD. PGS get out of the scaling
1 by
factor.
beta square.
Yes, 1 by beta square. Why? Because VDD is having a scaling factor 1 by beta. So VDD square means 1 by beta square. Ron is having a scaling factor 1. So it is the scaling factor for Ron is a 1, means 1 by beta square. Similarly, what is the scaling factor for PGD?
1 by beta square.
దానికి కూడా 1 by beta square వస్తుంది. So what is the overall scaling factor? PG కి ఏమవుతుందమ్మా? By beta square into 1. So 1 by beta square. EGD equal to EG into F naught. EG is having a scaling factor 1 by alpha square beta, and F naught is having a scaling factor alpha square by beta. Finally, it is equal to 1 by beta square. So PG ki scaling factor find chesam anukondi. PGS is having a scaling factor beta 1 by beta square. Similarly, PGD is also having a scaling factor 1 by beta square. So it is nothing but a 1 by beta square into PGS plus PGD. So it is actually the formula for PG. The scaling factor for PG is becomes a 1 by beta square. Okay, next one is it. మా నెక్స్ట్ క్లాస్ ఎంతకమ్మా మీకు 11th మనకి ఇంకా ఏంటి ఓకే ఒక 2 ఇంకా ఒక 2 ఉన్నాయమ్మా. ఈ రెండింటిని క్యాల్కులేట్ చేయండి. పవర్ డిసిపేషన్ పర్ యూనిట్ ఏరియా. ఆల్రెడీ మనం పవర్ డిసిపేషన్ క్యాల్కులేట్ చేసామమ్మా. వాట్ ఈజ్ గేట్ పవర్ డిసిపేషన్ పీజీ ఆల్రెడీ క్యాల్కులేట్ చేసా. పవర్ డిసిపేషన్ పర్ యూనిట్ ఏరియా మీన్స్ పీజీ బై ఏ ఆర్ ఏజీ, గేట్ ఏరియా ఏజీ. సో క్యాల్కులేట్ చేయండి ఇప్పుడు. నెక్స్ట్ ఇంకోటి కూడా ఫైనల్ ది పవర్ స్పీడ్ ప్రోడక్ట్. Product power speed product. Let us consider. Let us take it as a PT, which is equal to PG into delay TD. What is the power dissipation per unit area scaling? ఎంత వచ్చిందమ్మా పవర్ డిసిపేషన్ పర్ యూనిట్?
Alpha by beta whole.
Alpha square.
ఆల్ఫా స్క్వేర్ బై బీటా స్క్వేర్. నెక్స్ట్ పీటీ కూడా ఫైన్ చేయండి అమ్మా. PG is having a scaling factor 1 by beta square. And AJ is having a scaling factor 1 by alpha square. What is PT is having a, now tell me the scaling factor for PT, the power speed product.
Sir, alpha square by beta cube, sir.
Alpha square by beta square. దీనికా?
Yes, sir.
కాదమ్మా.
1 by
1 by
alpha.
alpha.
Yes, 1 by alpha square beta. PG కేటమా స్కేలింగ్ ఫ్యాక్టర్ 1 by beta square. TD కి ఆల్రెడీ ఫైన్ చేసాం మనం. Beta by alpha square. It is having a scaling factor beta by alpha square. So the scaling factor is 1 by alpha square beta. Okay, let's